I will explain the steps necessary to create an obstacle avoidance robot. First, assemble the chassis. Mount the 6 poles with screws to attach the other side of the chassis. Now, follow these steps. Put this piece as shown. Then, take another and pass it through the motor. Place the nut and tighten it using a screwdriver. When soldering the wires to the motor, pick arbitrary sides or just follow the circuit diagram. We need to increase the height of the servo motor. Fix the other part of the chassis and pass all the wires through. This is an ultrasonic sensor. We're going to use it to measure the distances between objects. This is an Arduino Uno microcontroller. It acts as the CPU of the robot. We upload all the instructions to the chip on the board. Make sure to subscribe so you can catch our next video on the Arduino microcontroller. This is a L-to-9 3D motor driver. It interfaces with the Arduino to enabling us run the motors in this project. Fuse the motor driver and the Arduino. This allows us to access the GPIO pins of the Arduino from the motor driver. Like and share this video to our electronics friends. This helps the YouTube algorithm push our content to more people. Connect the pins on the ultrasonic sensor to their designated pins on the motor driver board. Now we fix the ultrasonic sensor on the ultrasonic sensor holder. We forgot to order one, but that gave me an opportunity to put my craft skills to practice. We'd mount this holder on the servo motor using screws. Now we place the male jumper wires into the breadboard. The breadboard acts as a junction between the wires coming from the sensor to the motor driver board. This is because we don't have the female-to-female jumper wire. Use the female-to-female jumper wire for simplicity and to get a neater work. Now we connect the wires from the motors and batteries to the motor driver. Take note of the polarity of the battery to avoid damaging the board. Attach the ultrasonic sensors to the servo motor for scanning at 30 degrees increment from 0 degrees to 180 degrees. The components on this breadboard are to bridge the PWR pins on the motor driver. This design gives the user better control. It makes use of a 555 timer circuit in bistable mode, such that an output from pin 3 to the gate of an NPN transistor opens a channel, therefore bridging both PWR pins. If this step is too complicated, you can place 2 female headers on the pins, bridge them, and you're good to go. Write or upload obstacle avoidance code to the Arduino board, ensuring it controls both motor direction and sensor reading. There's a link to our GitHub repository. Make sure to disconnect PWR pins when you are about to upload the code to the microcontroller to avoid blowing up the board. Thank you.